Okay, so we're going around against the clock. I don't have enough time for everything I want to say, so feel free to come after for questions. And the little clock is the red bar under there. So I'll just quick show of hand also to get a bit more excited and to stretch a little bit because I have so little time. Who are more interested by VR than AR? More virtual reality? Okay. And who is more interested by augmented reality than virtual reality? Okay, so. And who is in the wrong room? Not here? Okay. Everybody's in the good room. So I'll start still with VR, simply because it's more stable, it just works better now. And instead of telling you how directly the code works, I'll tell you what I believe is the point of VR in the first place. So what's the point of virtual reality? So it's to do things you cannot do. It's not to do things that you should do, but you don't do. So for example, I should go a bit more often to the gym. I don't do that. I'd like to dive, and I haven't been for a while. I didn't take the time to do that. So I could do that in VR, but that's not the point. The point is for things that you really cannot do. So for example, I'd like to go on Mars. I've never been there. That's starting to be interesting. But maybe at some point, I don't know if you're optimistic on interplanetary travel, but I have my doubt. Maybe I'll be able to do that at some point. But on another galaxy, definitely not. So that's starting to be interesting, actually, I think, to be important. Or to visit hyperbolic planes or planes like there. That's where there is, in my opinion, value. But still, VR in itself doesn't matter. VR is the time you spend in VR can be interesting, can be entertaining, but it's when you remove the headset after those VR sessions that hopefully you've learned something, you had a good time, you can help your friends, or you can help your colleagues. So not the time in the headset, that's great, but it's the time after, once you remove the headset, that I think really has value. So one very concrete example that was done or shown a few months ago, that's from a prison in the US where inmates were able to use VR to discover or to train rather for the real world outside, to train back to society because, for example, I don't know, you have to step back and imagine that you've been an inmate for 10, 20, 30 years and then you go out and somebody show you something like this. You don't actually know what it is. And then you have interviews, you start to try to integrate, and all those little steps that are obvious for anybody else are not anymore. You don't know how, I don't know, to use a washing machine, to iron your shirt before an interview, and all the steps that are really obvious, you don't have access to. So I think that's really, really brilliant use of VR. But again, it's after, once you remove the headset, that it's important, not the time spent in there. So what's VR? VR is basically fooling your sense. It's being able to say, hey, here is what I see in front of me, and I move my head, I'm in the headset, and then I can see something else. And the image always matches your intuition, your point of view. So then you're not like wearing a headset, you're basically somewhere else. Hence the example of the holodeck there. How does that actually work? So I can spend the next 20 minutes-ish on telling you how actually the technology works and how the different sensors are working and how the data is being passed and how you can get your position in space, which is indeed how it works, but that's keeping the most important part of the technology behind VR, which is the human brain. So that's a little illustration from one of the most fascinating research I've read last week, actually, so it's still blowing my mind now. Those are beetles in Australia, and they are male beetles, and I don't know if you can really see what they're trying to do, but they're trying to reproduce with this gorgeous beer bottle. Because somebody there just like tossed the bottle away, but this, for this kind of beetle, looks like the most gorgeous female beetle. Because it has exactly the right color, it's a little bit shiny, has some dots on it, so it's kind of a super signal that, hey, this is exactly what I want to do, this is whom I need, that's my special someone. So what it's actually illustrating is that it doesn't matter really what you see, it's basically some interface toward that information that's actually useful to you. You don't see the world as it is, you see literally your perception are driven by efficiency, and this efficiency is making everything that you see for your own goal. It's not how the world is actually. And there are lots of, you can't really see the diagram at the bottom, but if you run some evolutionary simulation, you can see that or the population that are driven to get information realistically with perfect veracity just are driven to extinction. The population that are actually succeeding is the one that are aiming for fitness, so how information that you see is actually useful for you. And that's exactly how VR works for us. So yes, you've been warned about the pizza. I'm pretty passionate about VR, AR, but also about pizza. I love it because it tastes delicious. It has such a good smell, such good colors, and the problem is, first, I don't have one with me, and the other, so I can't share with everybody there. But the problem is, when you want to share a VR experience, it's exactly like trying to share a pizza with somebody who never had pizza. So imagine a friend, somebody really nice, you care for him or her, but somehow they never had pizza, and you try to convey, because you have to convince him or her to go to the pizzeria, because hey, that's where it's good. And, well, if you haven't tasted pizza, you just don't get it. So it doesn't matter how smart, educated you are. If you haven't put a headset on, you can come after and we'll chat. I actually have a headset there, and just put it on once. If you don't have time to catch me, you don't want to speak with me after, they're in every city, including Brussels, a lot of VR centers, so just go once. You don't have to like it. You don't have to think it's going to change anything, but don't assume, regardless of your education or even the complete understanding of the brain and the technology, that you understand what VR is if you haven't put the headset on at least once. Now we're at FOSDEM, but regardless of the place, I think VR, open source in VR actually is pretty important, because if you think back of the holodeck, I want to build a whole world around me, or my friends, or my colleagues. If I have some kind of arbitrary limitations, that's frustrating. But I think when you're talking about actually building a whole reality around you, I think it's more than frustrating, it's actually dangerous. And it can have some business implication, political, however you're going to call it. You might know the guy in the t-shirt. So that's why I'm contributing to Mozilla, because I think having the tools to build your holodeck and not have artificial limitations are actually pretty important. So what do I actually do? Like I said before, I contribute to Reframe. I'll detail what all those different pieces and tools are about. I do some pull requests, I solve some, I complain a bit, whining on some issues, trying to detail as much as I can what the problem is, documentation, because I discussed before, it is pretty important. And I participated to all hands before. I went to Asia to showcase and make people actually have their first time in VR. But arguably, maybe I like to chat too much, but I would say one of my most important contributions is just being there on Slack. So if you go on the Reframe Slack, with a little bit of luck, if you have your first time and somehow it doesn't work as expected, just ask. I'll probably be around, and I'll try at least to help you. Some other contribution is basically doing proof of concept or little demos, because I think those are pretty important. They look pretty innocent, but so to describe a bit like what you see now, you can use VR with some controllers. Again, if you haven't tried this, like to be able to see your hands and interact and paint, it is pretty amazing. And since I don't go to the gym that often, I thought I would train and play a bit of soccer. Obviously, then I need my hands to grab the ball, but also to have controllers on my feet to be able to kick the ball. So I just went to the kitchen, take some plastic wrap, and wrap them on my feet. Wasn't the most comfortable, but it actually did work. So I'm playing against a 3D model of myself. I scan myself, and I managed to lose, but training. So that gives me a full body immersion, meaning my entire body from all my limbs are there, and I can actually, the sense of immersion is even more present. So that's a silly little demo, but it hasn't been done before, and it's giving me a stepping stone, let's say one way to learn out of it, and I don't feel good about it. Visually it's not pleasing, but it was new back then, and I let others also experiment with it. So it's a stepping stone for me, little learning tool, but also for the community at large. So make ugly demos, because it's fun, because it's interesting, it challenges a bit, and also because then you share it back with the whole community. It's a whole new field, so we need to learn from each other. So that's great. I made my little thing. I spent a bit of time, but the point after is to be able to share it. So obviously, that's where the web is taking the most value. Is I give a link, you instantly can open it if you want to, and we can collaborate on it. Then the question is, okay, that's cute, but can you actually do 3D on the web? So I took, because it's a question that comes pretty often, I have a bunch of examples. We won't have time for all of them, so don't worry about it. The links will be at the end of the presentation. So, for example, so yes, all those are in 3D. You have some kind of reflection. You have, for some of them, physics-based rendering. You have different effects, and it's all running there. It's not, if you're wondering, okay, that's cool, but it's on a super powerful machine. The graphic card is an HD 620, which is basically the cheapest integrated chipset you can have now on a laptop. And this one also, so it's all in real time. You can just look around. So that's 3D on the web. So yeah, okay, if you look at the latest Unity Unreal demo, not exactly the same, but I would argue that's pretty convincing, let's say. It's not just a cube or a sphere. And there are, again, plenty of other demos to explore that. So I'm sorry regarding the previous talk. I didn't include directly the MDN tables because for WebVR, it wasn't really there and I didn't have time to edit it myself. But yes, you can still use can I use. So 3D on the web works, and VR basically on the web works. It doesn't work everywhere, but for example, this big column, which name I won't mention, is full of flags, so it's mostly working, and it's working pretty much on mobile too. So it doesn't work everywhere, but on mobile, on HTC Vive, Rift, Windows Mixed Reality, it's working pretty well. And then you have polyfill also as a trick. Even if you don't have a VR headset, you can still use it because you're on the web. You can still use it with just quote-unquote a laptop or a desktop, a tablet. So yes, you do aim in the end for your headset, but any device will actually work. And the web is not just like a lower version of native. I did show an example just before, 3D on the web, but it's not just a port, let's say, because, well, first of all, you can have everything you can roughly from native, but since also mentioned before, using Service Worker, you can have an offline version. So you're using a web page, you don't have a connection, it still works. So that's pretty good for this kind of experience. And also, you can do things you cannot do just in native. So if you're epileptic, close your eyes now, because the next slide is disco. So here we're diving from one VR experiment to the next. And there are just pages, just links. So for example, if you make a page, and then you make a page, and I make a page, we can link to each other without asking for permission, and that's without removing the headset. If you do that using native, then you will have to go back, let's say, to the Oculus Home or Vive Home. That's just not possible in native. So that's cool, but how? Well, you can code for it, but let's say you don't feel like it on this day. Well, there's this little logo you might recognize. That has been done literally by taking your controller and painting those strokes in space. You have a one-to-one mapping. So it's using a painter. You have the link also in the reference and the logo there, but you just paint the tail here just by doing the movement in space. So it means you can use VR not just to consume content, but also to create content. If you want after that to, so that's a little bit more of the interface, how it's working. So you just have your first controller that can be a palette of the different brushes, the different colors, and then again, just that movement. You can paint with both hands. You can be pretty fun. You start dancing and everything. Can be pretty serious, of course. You can do serious 3D assets, but and if you have tried Blender, it's an amazing tool, and it's not exactly the same usage, but then doing this kind of complex meshes is pretty tricky. So for somebody like me who can just do that, that's a good way. The inspector, on the other end, the iframe inspector allows to just, you would expect from a 3D editor to grab an object using your mouse or your keyboard and then change the scale, its position, etc., again, without coding one line. A frame itself is the framework behind it, behind a painter or the inspector, that allows to actually code for it. So I'll do a quick example. So let's see. It will be mostly copy-paste because I'll excuse time. So I'll just go on the aframe.io website. Because I don't know what I'm doing, I'll go on the documentation. And first link, well, there is a bit of code there, but I don't need to get it. So I just click on Remix from A-Frame. Remix your own. I cross my fingers, of course, because last minute problem, demo, this probably won't work, but let's try naively. So that's about 10 lines. And that's it. I have here my little 3D object. So you're not sure, you don't really believe me, first time, it's normal. So here the box is blue. So I will make it, give me a color, yellow. I don't know him, huh? It's not magic or something like this. And it's yellow, yes. So, jokes aside, that's an actual URL. So if you go now on bug-close.glitch.me, that will work on your phone. Don't go there because connection and all this, but if you could go, you would. And if you have, for example, the Vive or any kind of high-end headset, that will work. So it goes from high-end to actually not VR, to low-end VR, to high-end VR all the way. So that took about 1-2 minutes, basically, to have literally nothing installed to create content, and also nothing installed to consume content. Okay. I recommend this book. Okay, so you saw like one cube, one cylinder, one sphere. You're not really impressed. So it starts from really, really simple to going really all the way down. So if you're a graphic programmer, then you can go all the way down to shaders, because it's nice to have those basic visuals, but if you want to have your own either special effects or deformation of 3D objects, you can use that too. So there are a lot of really cool websites to learn how to do that and then to integrate it back. So why also I insist on it is because once you know that it's shaders all the way down, it means it's executed on the GPU using WebGL, and it means it's pretty close to native. I would argue 90–80% performance-wise. So again, yes, it's on the web, but it doesn't mean it's like a lower version of native. If you don't want to write your own component to change the behavior of your object in space, then you can use directly, again, without copy-pasting, the repository with tons of different components. It goes from very simple one, like I don't know, a mountain, to motion capture. So if you have an object in space, yes, you can draw it, but then after that you can animate it. So it means instead of like coding the line, you just take the object, move it around, replace play, and then it's like a little rabbit jumping, for example. And then you have physics also, so you can actually just, again, straight from the browser, have your rabbit, you don't want to throw the rabbit away, but let's a ball of basketball, then you can make it bounce. So a little summary of the tools. A-frame is the framework, so if you want to code in GLSL, in custom element, the kind of pseudo HTML as I showed before, JavaScript, and import whatever library you want, you can use that. The inspector is to put them in space. The repository is for all the community third-party components. A painter is to paint, draw in VR. And then because we're still at the beginning, whatever you also want to do, well, it's whatever you want, you'll share. So I'll keep those Q&As for the end. Just one Q&A that's there is AR better than VR? Yes, no, it depends. It's not the same thing, basically. So the second and last part is about AR, specifically augmented reality. So let's imagine here, instead of having this nice bottle of water, I had actually a delicious Trappist beer. I won't give any brand, but it's not actually there, but I wish it was there. So that's basically AR. When you have the illusion where you're not like with the headset directly secluded or blocked in this virtual world. I would say the biggest limitation for native AR that people don't download apps. So if you're Facebook, if you're WhatsApp, if you're Snapchat, that's cool. You're okay, but if you're not in the top 10 and you spend hours and dozens of days to make your AR app, nobody's going to actually download it. We still download it now because there is some kind of novelty factor, but bit by bit it's wearing down. And I think even if there wasn't this novelty factor, if you spend more time installing an app than using it, there is somehow a kind of problem. So since most AR applications are just a few minutes long or little bits of information, what I like to imagine is they were just like finger food, basically. You just have a little bite, but if you spend more time actually preparing and then sharing it, there is clearly a distribution problem. Obviously, once again, the web to the rescue. So that started a while back, meaning about 7 years ago or 10 years ago at Georgia Tech. There were Blair McIntyre, who is now at Mozilla for the XR AR project, started a browser to do AR. Where does it work, on which hardware? I would argue everywhere-ish, in the sense that as soon as you have a camera, you can do AR. Not amazing AR, but you can already superimpose whatever 3D or 2D object in front of reality. The more hardware you have, well, the more interesting it becomes. But also the trickier it is, because then you are going to have to go from general browser to more custom that you'll have to actually either build yourself and compile and send. So the more hardware and the more advanced the usage, the trickier it will be. So if you just want to superimpose on a camera, whatever commodity hardware will do. The easiest way to do it now, if you have an iPhone or any kind of modern iOS device, will be to get the XR viewer. So I'll do a little demo with this. I'll show first how it works. I'll hope So that was in my kitchen yesterday morning, was kind of clean. And then you see the grid on the floor and all those little yellow dots. So the yellow dots are a point of interest, basically where you have sufficient amount of contrast, and then it's unique enough, let's say, so that when you move the phone, it's able to localize itself by inverting, okay, the points are getting further or closer away, then I'm getting closer or further away from the previous location. And yeah, I used my hand, so it was pretty stable, did not lose the position. So yeah, that's how it works, finding those little yellow dots and then moving around to see if they move from the last frame, basically. And then once you have that, when you have your position relative to points in space, you don't have to show them, first of all. It was just to explain you how it works. And then you can put objects in space. And then you can put sort of permutators and start to play around with this. And it doesn't have to move. To show a little bit the degree of precision, then this is in my salon, not in the kitchen this time. I just put the first, or actually all my little anchors that have their position in space, and a meter that I had from wherever, and then it's about 2 meters, and then you see the measure, it's more or less 2 meters. If you're already familiar with 3GS, which is basically the default choice if you want to do 3D on the web, or no, let me say it another way. The most popular way to do 3D on the web, then all those utilitarian functions like distance tools, you hit the first point, the second point, and you just get the value, you get the distance, it's out of the box. You don't even have to do all this kind of difficult mathematics yourself. There are, though, some limitations. It's not magic. So, for example, now if you use ORCID or a core, which is what XRViewer is using, it only knows flat surfaces, just the plane. So if you want to make an object, let's say a window, or if you want to make it move, you basically have to position it on the floor, and then bring it up. So I did like a little menu on the side, and then you're able still to have your object vertically moving. And yeah, you see the little box there in the back. It's because it's just a 2D camera. So it has no notion, it's not a depth sensor, so it doesn't have a notion that this object is behind, let's say, this shelf or this other object. So it works, but with some limitations. So that was 2 days ago. If you want to prototype for AR, you don't have to buy a $3,000 or euro HoloLens. You can take the top of your Tupperware and then start to simulate how or what the different actions will be. It's not great, but actually if you want to convey to a friend or a colleague how it works, it's pretty efficient because you can start to say, hey, I'll measure this space and then I'll move it around, because that's basically the display you'll have with your phone if you do it. Demo time, second demo time. Okay, we'll go super fast. Let's see if it works. Doesn't matter, let's try. So, you can see my phone, yes. Okay, so I start the XR viewer. Oh no, it shows everything already. Don't look. A bit of suspense. Okay. You can still see, yes. Okay. So I'm looking for the little yellow points I showed you before. I can actually show you if I see. So I don't see, I see some, that's good. Okay, so this is a bit, I have my grid. And then I can put my objects there. Hopla. And if I turn around, they're anchored in space. And that's it. Okay. You see, yes. Up. So how does it work is, again, I import A-frame to be able to position my object in space. And then using the A-frame XR library, then I can use actually the camera of the phone as a pass-through camera and then to localize myself in space. And I can still use all the syntax, those custom elements in A-frame I'm familiar with. Okay, that was this. Yeah, again, why it matters is because I think AR is a pretty powerful medium, but it's a new medium. If we are already trapped within some kind of proprietary ecosystem, then we can't actually explore. And that's not the kind of future I want. So I want to be able to go wherever I want with it. What's actually yet to come, so for VR, obviously we want higher pixel density. If you have tried VR 2 or 3 years ago, try again, because if you try a Vive Pro or Samsung Odyssey, the pixel density is pretty good. So you can still, if you focus, see the pixel, but you nearly don't see them anymore if you don't pay attention. For tracking, it's a better position. As you saw, it was a little bit, maybe my phone was stressed by the presentation, but it was not perfectly aligned. So that's also with a depth center we have in more and more autonomous cars that's getting to go way cheaper and they're way more popular. And finally, better unification with WebXR. So a little extra on this. So last part, which actually lasts 3 seconds, is to say just that WebXR is actually WebAR, WebVR, and WebMR, and Web whatever are. Any kind of reality is now under WebXR specification. Specification might sound a little bit abstract, but if you're interested in the field, it's a pretty open discussion. It includes all the different browser vendors, all the different parties interested. So I invite you to join the specification to see how it works, and also to share your needs on it. Absolute last slide is don't trust your perception. It doesn't matter if you do AR, VR, or something else, as long as you build useful interfaces. That's what matters. And that's it. Slides are there. You can just search, and all the references are there with the example. Thank you.